am Prachi, and today I will be presenting this paper, a perception-powered urban digital twin to support human-centered urban planning and sustainable city development. So this paper was published in September 24, and so this paper focuses on the combination of objective data and its relationship with subjective perception and its use in urban planning. So this will be the outline for today's presentation. So first I will be covering urbanization and its challenges, and then we'll see the research gap of the study, and then we'll see the key concept of this approach, which is urban digital twin and their capabilities, and then I will be explaining methodology, and then we'll see result and key findings, and then we'll move forward to conclusion. So what is urbanization? So urbanization is a situation where people from rural areas move towards urban areas, so which in return cause urban growth in cities. So urbanization is having both positive and negative impact in the society. So if we talk about positive impact, so urbanization can improve the economy of that particular place, and it will help in development of the infrastructure of that particular place, and it will make the city more inclusive and culturally rich. But if we talk about negative impact, so it will make that place overcrowded, and it will affect the environment of that particular city, and due to overcrowdedness, it will cause the social inequality, and it will arise the privacy concern. And so now we'll see the challenges of urbanization. So as cities grow, we need a urban plan which can fulfill which can plan a city in such a way that it can be functional and it can fulfill the need of its citizen. But it is very challenging to fulfill the need of every citizen during planning phase. Second, integrating public perception. So it is important to consider the experience of its resident into the planning phase to provide a feel of security to its residents. But traditional approaches of correcting perception and experience of human is very time consuming and very expensive. So it is not feasible to collect it. Third, navigating urban planning complexities in limited space. So as cities grows, the city space limit is very limited. So it is very challenging to plan the city in such a way that it can be accommodated. It can provide accommodation towards all the citizens. Fourth, privacy and data security concern. So as several technologies are being used in planning the cities, so it is raising the concern of privacy and data security of its residents. So it is very crucial to use the data of user in such a way that it can keep secure their data. So what is the research gap in this domain? So mostly urban planning research focuses on the physical parameters such as environmental monitoring, in which green, heat island and vegetation index will come, and physical parameters such as transmission network and energy grid will come in this, but they are not focusing on the relationship, they are not focusing on the subjective perception of it. For example, if we are building a park and it is having sufficient space and it is having covering green view index exactly, but it is fulfilling all the physical parameters, but it is not fulfilling the need of its citizen, like whether they are feeling safe there or not, and they are feeling livable there or not. So this is not so it can't be useful and it can't be utilized by its people. So it is very important to consider the subjective perception with the objective data. So why this subjective perception is required. So as I told you, if we are not considering the subjective part, then the place will remain underutilized and it will somehow affect the well-being of its citizens. How we can plan a city in such a way it can be both. It can include subjective and both objective form. So UDT, urban digital twin, is a concept which is used in urban planning. So what is urban digital twin? So urban digital twin is a dynamic digital representation of a physical environment which can mimic the properties of real world. It is not just a 3D static model. It can integrate real-time data from various sensors and UAVs so that it can behave like a physical city. And it should the relationship between UDTs and physical area should be bidirectional, which means if we are doing some simulation in the UDT, the outcome of that simulation should be used in the real-time development of the physical environment. So there are various application of UDTs. So first is simulate and analyze urban scenarios. So we don't.
I couldn't understand the bidirectional thing.
Bidirectional with the up, like you are there is a urban digital twin and you are there are some transportation thing and there are some building, and if you are adding some building there, new building there, so what are the consequences of building that building in that particular environment? So you can see what will be the outcome, and then those outcome will be similar, which when you develop that building in real world environment. So bidirectional means that it should replicate the. So simulated analysis urban scenarios. So in this, as I told you first, we don't need to build something in real life, in physical manner. You can just build the model and you can just see how we can add the how we can change the infrastructure, and how we can plan the transportation, and then we can build those things in real life. Optimize urban infrastructure and services. So here we can optimize the transportation time, energy grids, and then we can replicate those planning in the real life scenarios. Enhance disaster preparedness and responses. So here we can add some disaster scenarios such as earthquakes and floods scenario in the UDT environment, and then we can based upon those environment we can decide the responses, and we can plan those responses for real-time disaster when they will happen in real life. Facilitate public engagement in urban planning. So with the use of VR and AR, we can provide VR and AR to its citizen, and they can feel the environment through this urban digital twin.
You might even be into it. Do you know what a digital twin is? Essentially, it's a digital version of a physical object, a dynamic, up-to-date digital replica of a built asset or environment. With the help of building information modeling, artificial intelligence, machine learning, and Internet of Things technology, data from the original asset is used to build and improve the digital twin. By providing a precise, up-to-date model of its original, a digital twin can help designers, engineers, contractors, owners, and manufacturers create more efficient structures. Digital twins can help with everything from planning, design, and construction to operations and maintenance. Consider a building that's already been designed and constructed. Imagine there's a digital twin of the entire facility, from the roof, the HVAC, to the mechanical, engineering, and plumbing systems. Now imagine that sensors in the building provide the digital twin with real-time information. The digital twin updates itself according to the data. Then building owners can view areas where the building is aging or faulty and make improvements. On a greater scale, multiple digital twins can be integrated in an entire ecosystem. So, how did digital twins get their start? In the 1960s, NASA was one of the first agencies to use mirroring technology to replicate systems in space. Notably, NASA created a replica of Apollo 13, which became critical in the midst of its challenging mission. Engineers were able to test solutions on the replica to avoid further disaster. Dr. Michael Reeves, chief scientist for advanced manufacturing of Florida Institute of Technology, introduced the concept of the digital twin at an American Society of Mechanical Engineers conference in 2002. He proposed a product lifecycle management center that contained the elements of a digital twin: the physical space, the virtual space, and the flow of information between the two. The manufacturing industry was quick to adopt digital twins, and the architecture, engineering, and construction industry followed suit, with the help of technological advancements like BIM, or Building Information Modeling. Today, digital twin technology plays a big part in the digital transformation of the design, engineering, construction, manufacturing, and maintenance industries. A digital twin starts with knowledge of the assets and spaces that make up a facility. This type of descriptive twin is a live, editable version of design and construction data, such as a visual replica of assets or facilities. An informative twin has an added layer of operational and sensory data. As more and more data is added, the twin becomes richer and richer and more strongly linked to its physical counterpart. Predictive twins are able to leverage this operational data for insights, while comprehensive twins simulate future scenarios and consider what-if questions. In the future, twins will become autonomous, able to learn and act on behalf of users. Because digital twins can gather key information about things like population growth, natural resource supply levels, and historical data on environmental disasters, they can help build more resilient cities and infrastructures as the world changes. Eventually, an entire ecosystem of digital twins will help industries respond to global challenges with powerful, simultaneous changes. Right now, digital twins are helping operations and facility managers respond faster by removing the need for complex and time-consuming maintenance documents. Owners can gather information from the design and build phases to make faster business decisions, lowering operational and maintenance costs. Professionals on-site can predict material and labor cycles, reducing waste and enhancing safety. By helping professionals gain more insight into the inner workings of the world, digital twins are becoming partners in building a better future.
So, this video was showing how innovation of digital twins. So, despite having so many applications, Unity is also having some limitation. So, first is which this paper is dealing with limited integration of human perception. Second is data availability and integration. So, data is the basic of Unity because it required real-time data to build a real-like Unity. Relies on manual 3D modeling. So the biggest challenge of Unity is manual 3D modeling because there is no automated technique to build the agile digital planning. So it is costly and time-consuming. Discrepancy between virtual and real-world experiences. So for virtual experiences, they are using VR and AR technologies, but those VR technology is not sufficient to capture all the complexity of physical real-life environment. Last is ethical consideration regarding privacy and surveillance. So, like most of the urban digital twins nowadays are collecting data from social media and their smart devices. So, it is not very safe to use those kind of data. So, it is very important to secure, to build some algorithms so that they can't use the personal information of their users.
Here, the AR/VR technologies, are they using Unity or?
Unity, like in Unity, if you are if you want to experience in real life, then you need to use VR technology to virtually experience. So, like in this methodology, they are using for collecting subjective perception. So this is the methodology of this paper. So this methodology is This methodology is considering 5 steps. So first step is 3D model subsystem. So here they are developing this. So here they are developing this 3D layout, which is the basic of developing urban digital twin. So this is like most tedious task because they have to do it manually. Second is data collection subsystem. So they are using UAV data and some sensor data, and apart from this they are using Mapillary API data so that they can use crowdsourced data, and they are also extracting the GPS location of those images so that they can perfectly align, so the images can be perfectly aligned with the physical infrastructure. Third is visual characteristics analysis subsystem. So here they are using two things. So they are using DeepLab v3 for semantic segmentation so that they can calculate green view index, sky view index, and sky view index, building index. And they are using, so for 3D modeling, they are using Reno model and Grasshopper model. And for adding materials and texture quality, they are using Luminon software as well. So from visual characteristic analysis subsystem, they are extracting the objective data by doing semantic segmentation, and then immersive virtual reality subsystem, they are using VR technique to collect subjective data, and then they are using their random forest method for perception analysis. So in the next slide, I'll tell you this in detail. So this is the whole workflow of this approach. So in the first part, they are building, they are like deciding the study area, and then they are building 3D model. So there they are considering 6 digital layers: terrain, water, building, roads, and vegetation facilities. And then they are using they are doing data collection. So data collection is done by GoPro camera and UAV, and through online Mapillary website is also used for collecting those data. And then they are they are extracting the GPS location of those images. And here in the third step, for these images, they are doing segmentation, and they are calculating green view factor and hard ground view factor, which is like road, building view factor, sky view factor, and dynamic factor means vehicle. And these field of view area, field of view parameter, height to width ratio, these are being calculated with the Grasshopper software. After this, they are doing subjective visual perception. So here they are using VR method, and there are total 120 participants which are providing ranking to each images, and the scale is 0 to 7. So
why do they need GPS here?
like to extract the information lat long values, and then like to perfectly align those images with the physical environment it is required.
But I mean, it is totally the perception taken through that AR/VR technology.
हाँ,
right?
परसेप्शन वाला पार्ट तो अलग है. पहले तो डिजिटल ट्विन बनाने के लिए उनको एग्जैक्ट रेप्लिका बनाने के लिए वो लोकेशन तो चाहिए पड़ेगा ना. And then they are using in the fifth step, they are simulating the environment, and then here they are using random forest method for predicting the subjective perception and their impact. So this is their study area of Singapore, so which they have selected for their study. So this is the real location, and this is the virtual counterpart of this location. So this is the overall comparison of objective indicators which they are taking.
3D digital twins has a like application in the sense of scalability, or like they are using in between somewhere to increase the data, or like they are using the collected data what they have collected during the survey.
For what?
For calculating the perceptions, and all they are using just the data which they have collected using the GoPro.
Same, GoPro.
And then what is the use of the digital twins there?
It will give people the sense of like they are roaming in a particular environment. So that is why they need urban digital twin, because it is not feasible to go in every place physically to collect the perception data. Because otherwise you have to go to collect perception data separately, and then you have to build you have to use some software for urban planning, and then you have to integrate both of them. So it is better to use one thing, and there you can.
No, the thing is, wouldn't it be more costly if you were using your own hardware devices to capture data and then asking people to AR/VR technologies to classify them as?
AR/VR is not used for classification.
I mean, for perception, right?
But it is also possible if you are going some places and you are collecting
No,
service.
I'm saying if I directly hire people from that particular location, won't it be better than this thing?
But it will not be that much feasible, I think.
Go back to the what methodology. What is the data used from the first step and to where?
Where?
Like 3D model and layers are there, right? And now it is used where?
So this 3D model is the basic layout of urban digital twin.
Okay, it is digital twin is there. Now you are going in a particular path to collect the data with the GoPro. You have the images, right? And now you are with the help of segmentation models, you are doing the segmentation, and you are collecting the perception with the help of the AR/VR technology, which will come from which will happen to be the images from the GoPro, right? And after that, what happens? But what is that fifth step?
A simulation.
Can you tell about it?
This rendering of that.
Basically, what everybody is asking is what is the need of this? If you already have the data from ground, why do you need it? So if we go back. If we skip this number 1 and just utilize these images, make it number 1, and instead of this virtual reality, if you do a manual survey or any sort of, let's say, Google form based survey, how would this be beneficial?
Because in manual way we'll be just showing the images to the people, and here they are experiencing, like they can virtually travel to some places, and then they can tell they are feeling.
They will get a 360-degree view.
Yeah. Panorama is 360 view.
Panorama will also give you very similar sort of 360-degree view. So why should we need it?
Even if you take the Google Street View imagery as a panorama from there, then you can also visualize that in the 360 point of view. And similar way you can collect.
But what I think is it will be difficult. How then you can integrate this thing in your planning, city planning.
Output is going to be mapped. Mapping can be done in 2-dimensional or 3-dimensional information. So here your input, one number is going to have some important impact. Let's say if I remove number 1, how would the number 5 be impacted?
So fifth step is just rendering.
Read it carefully. Photorealistic scenario simulations. And then in image, the same place is being demonstrated in 2 different ways. In one time your chair becomes brown, next other time your chair becomes white.
I think this is real and this is simulated.
No. Because in 3D you can do something, that's the answer we want to.
So in this setup we can manipulate the scenes, and we can get more diverse scenes, and we can get more diverse perception data.
Some more things can be done. Can you capture street view in night time, rainy season, snowy season?
In this setup?
Not in this setup. So I am giving you hints why one is needed. Let's say if I don't have one, can you capture street view images for all the different possibilities for mapping the perception?
No, it is a challenge of collecting perception data.
Then how the 3D is going to help there? That is number 5th. But now I have 3D models, the twin models. Now I can make changes whatever I want in that 3D model. I can simulate light, I can simulate anything, I can change textures, I can put humans, I can remove humans, I can put objects, which is very difficult to do in real moment. So now when you have these all multiple scenarios, you can capture all the perceptions in every scenario. And then it should represent this place. Otherwise, let's say if somebody from your home comes in front of our building and he only sees this place once, then he will go back with a different perception. Maybe in the afternoon it's going to be a different perception, someday it's going to be a different perception. So the ideal perception of that environment, either you should have multiple layers, or if you are combining it to give it just single perception value, then you have to consider all the possible scenarios. That's where this will come.
But in this paper, they are not talking about manipulation.
No, that's the photorealistic scenarios. Scenario simulations.
In one slide, I guess yes. Yes. So here they are adding some scenes, like here they are adding building, and they are removing this greenery, and they are seeing what its impact.
That is scenario. So if you are going to plan something, and if you can pre-test that up before planning, will this place be safe? Then you don't have liberty to construct a building, cut a tree, and then make a decision. So you can do it in twin, simulate these things, and then give you the answer. Go back and then again start from the place where we left the discussion. Not here, maybe you were in other slide. You should put slide number. Go ahead. This was the place where we were. Now
So this is the study area. So they have selected Singapore as a study area. So they have taken 20 to 40 meter stretch. They have taken 3 kilometer long pathway, and then they have collected the data from there. This is the simulated result of that. This is the result of UDT, and this is the real photograph of that particular place. So this is the overall comparison of objective indicators. So here you can see this, this is the urban greenway which they are taking for their study. So here in this evaluation you can see the average value, hard ground view factor is having the highest value here. So this greenway is having hard road value more, and this DF dynamic factor, in this greenway path, dynamic less vehicle are traveling in this particular route. And if you see standard deviation, so this green view factor is having more most deviation in the particular route.
I didn't get what is GVF?
GVF is green view factor. So through semantic segmentation we have calculated green view factor, building view factor, and sky view factor.
All the factors how they calculate.
So hard ground view factor is how much this road area you can see, and green view factor is how much greenery is being classified through this semantic segmentation. Building view factor is for calculating the percentage of building there, and sky view factor calculates the sky visible sky. And dynamic factor is moving vehicle which are passing in that particular route, and those three field of view area, height, field of view parameter, and height to width ratio. These were calculated through Grasshopper software.
What is this height to width
The height to width ratio, like they are calculating the ratio of bit, like height and width of particular buildings.
ratio? It's just for buildings. Do we have some example with images?
No, for this.
I think this should be for lot many things. Height to width. अरे वो बच्चे
Field of view area, so how much area is being seen through this model, and field of view parameter, like how much parameter is
How
visible.
is both the things different? How do we calculate them differently when we have an image? So now we have segmented all of them.
Yes.
How do I calculate field of view area? And how
So
do I-
those three are being calculated with the software, Grasshopper software.
No, but it must be utilizing something which we are giving it to, some logic behind it.
Why we are calculating?
For calculating this objective analysis.
What is our interest?
Like these parameters, green view index and hard ground index, how these are affecting the perception of particular
So are we making a correlation
between subjective and objective like features.
Who is giving subjective information? Who is giving objective information?
The third block, like semantic segmentation and this spatial analysis algorithm parametric, which are like this field of view parameter, height to width ratio. These are providing objective, and this subjective perception is done by this VR method. So where 100% participant have like given the ranking to each images.
So now we are relating it and using random first to predict it.
Yes.
So how would this field of view parameter gonna play a role?
Field of view.
Perimeter, sorry.
So through this. And so here they are using this SHP analysis. So
That's not the question. Question is in the image. Given the image or given a 3D model, how do I calculate both of them and why they should be important? Something is calculated from images. Building view factor, sky view factor, hard ground factor. Something is being calculated from 3D. Field of view area is calculated
so those three, field of view area, field of view parameter, height of it is calculated
from
3D model, because they are
From
using
3D
Grasshopper.
So what do you mean by field of view area? That means, because everybody wants to understand that if we are using 3D to calculate it, why 3D is needed here? Why can't it be done through 2D? That's when their question can be answered, no? That why do you need 3D? Because you are pitching for 3D, so you need to explain why 3D should be important in certain aspects.
Because it will be calculated from the top of.
So in these parameters we calculated from some drone or something. That to say that
These parameters, these are calculated through some software.
the software is some whatever like data you feed, then software has some formula and then it calculates. You don't know these calculation mechanisms, but you should have known only these. Even if you would have known bottom three and not top, then it would have been something we should.
Because सर मतलब ये वाला पार्ट इतना डिटेल में नहीं थे कि वो कैलकुलेट किया है.
That you have to find out what is the meaning of field of view area. Otherwise, what is the use of pitching that 3D is needed? If I can't explain, or if I don't know what 3D information is being used, what is the need of saying that 3D is needed?
Like how much area is visible from the top of?
But I am calculating perception from a human point of view. So I am looking the area of the road when I am standing on the road. That's why he is mounting the VR set and looking at what it is visible to him. So he won't be related to something which can be visualized from top. Something which he is viewing in certain area, that would be the answer of these things and why 3D can happen or help you.
See, whenever a person is at in a ground floor, maybe the visibility is not on the high-rise buildings. But if you go to the top floor, maybe you have very good visibility. So it depends on the perspective.
Go ahead, you go back and see why they are needed. Otherwise, they are just numbers with less logic.
What is the data size they are using? They are taking the 3 kilometer and every
10 to
30
20.
40 meters they are taking the
Or is
images.
20 to
So
40 meter.
how many images it becomes?
Image size is not 20.
3000 divided by 20 or 30, those many images should be good enough.
See, it will depend on the area also. If there is a highway, maybe everything is visible. Most many things is visible. Maybe sky is
Greenway
visible.
areas.
Huh?
Greenway, urban greenway.
But basically, when you are considering these things, maybe if you go into some alley, so maybe the visibility will decrease. So you have to get some overall statistics. Maybe that is better, I guess. Yeah.
So this is the graph of this table. So here, like this, here you can see the average of HVF is high. So here you can see HVF.
Go back to that table. What does that mean? FBP 2.688 average. What does that mean? Means how to interpret that number?
Like how much field of view area average value is being captured.
In what units?
Maybe some receivers.
See, that is the issue. Until we don't know what is the formula, what is the method of understanding what is field of view perimeter, we won't be able to make sense out of the numbers. Otherwise, they are just tables put in front of us and we can say this is 20, this is 30, this is 40. Okay, go ahead.
So this is the subjective indicators, like subjective analysis. So it is a greenway area, so you can see people are feeling safe here. So safety is getting highest point among these, and like this area is full of greenness. So depressing indicator is having low value, and limited people, like some people are feeling like there is a more standard deviation in the boring parameters.
So, this, for someone who is looking at these numbers, if I am urban planner, what are the statements that you can make from row number 1, row number 2, row number 3, number 4?
Okay, so like this greenway is safe for most of the people because it is getting more average value for
That I can interpret, but what is the planning statement? Because you are talking in terms of urban planning.
Yes.
So what is the planning statement you will pitch to an urban planner who has no relevance with the numbers?
Greenway is more safer, like in greenway area people feel more safe, so you can.
But the numbers are same for everything.
For wealthy and safety, it is same.
Wealthy 4, safety 4, depressing also very near to 4, boring also 4, beautiful also 4. So what should I make of it?
But if you see maximum value, so safety is getting maximum value as well, 6.083.
That is fine. The range is, I am an urban planner. I am not somebody who knows numbers. So you have to give me planning inputs, not the number inputs. So what would you say to me that you have to plan in this way because these are the numbers?
So sometimes correlation is not actually causation. Maybe a wealthy is related to, may not be related, but you will get some correlation maybe.
मैक्सिमम वैल्यू कितनी हो सकती है, मिनिमम कितनी हो सकती है?
The range maximum 0 to 10.
What should I say? I will give you an example. If you want, say let's say I want to construct an ideal space, which area I should look at? The area which gives very similar scores for wealthy, safety, lively, depressing, boring, beautiful, or let's say the place which is wealthy, depressing, boring. How should I develop something? Let's say if I have to develop IISER, which metric should be influential?
Safety, lively and beautiful. Because wealthy is...
So they are trying to give the already existing what average exists. So now how you can increase the particular, I think, perception. So that's analysis further.
These are the average values of the perceptions.
Perception
Subjective
in a particular
indicators.
area.
That is also that is what even I am saying. That if you are getting very similar average value for all the perceptions in an area, so what do I make of it as an urban planner?
You can, like, by using these parameters, you can enhance that particular place.
That I can say 4.7 it's wealthy, 4.8 very safe, lively, numbers.
So you can make more safe because, like, most, as you were saying, most of the values are similar. So you can plan something in such a way like it will be more safe.
Let's say this is the number for Bhopal, certain areas. Overall for whole Bhopal, how would you use these numbers to plan, let's say, something which is coming up in body? Because BDA is planning to construct a lot of things, and now they are looking for these numbers. Because we all complain government is not planning. So you give the statements to government that you have to plan, then you will get this sort of metric.
So do you want to minimize or maximize some of these features?
So they are just presenting the relationship between objective and subjective indicators.
If you the question was
Mhm.
asking, so maybe you like the municipality doing some modification, like some some infrastructure development. There maybe they want to minimize boring, they want to maximize beautifulness, this kind of thing maybe. So maybe it is possible to get some sort of objective function by combining these measures.
This is the answer.
So
But when you give something to a planner, that I will give you a suggestion, what should come up in this area in what way, then these metrics combined with some analytics can give you the answer. What percentage of what should be planned, so that I don't want an area which is very boring, because that lies very near to commercial area. So give lesser weightage to boring, higher weightage to, let's say, lively, because it's more near to commercial area, that will attract the nucleus. So see, getting number is very easy. The task of all those analytics is very easy. The real challenge lies when you have those numbers and you actually want to implement it. So once we have these numbers, it's our task, if we are actually into the planning, to make it more understandable to somebody who is actually going to use it to plan. Otherwise, these things will keep adding up. You will publish some paper, somebody will publish some paper, numbers from 4, accuracy becomes 2% higher. What are we doing on the ground? So we need to understand how it is going to be applicable. Then only you will be, when you will write a paper, then only you will be able to write a discussion section, then you will be able to make sense what to pitch in the paper.
This is the result of random forest method. So here, like beautiful is getting highest score.
We are predicting beautiful in the best way. Why?
Because it is surrounding, like it is a greenway area, so that is why people are feeling more.
So because of the greenery. So if I implement the same model for, let's say, Delhi, will it perform very similar way or different way?
Different way because more, like there will be some other factors as well, which will be.
For you, do you believe beautiful only lies due to trees?
Because of clean air and aesthetic buildings.
So for you that means beautiful is something extra. Maybe it's just specific for Singaporean people.
Yes.
So these should be the interpretation. How? So let's say if I ask you 120 people were part of that survey. Who were they?
Like 50% were the urban planning, student or faculties, and remaining normal citizens.
But they don't represent the actual people. Let's say if we do it for this city, they don't represent Delhi guys. So that's one of the major challenge, how to generalize the subjective perception.
So for that we need to collect diverse, diverse survey. So this is a self analysis. So where they are calculating like some particular parameter, how it is being, like how it is like impacting. So here they are taking the. So how self analysis is performed. So first they'll calculate the baseline. So there where they are not considering any parameter, and they are just calculating the average value.
What does this show means? How do I interpret this graph? Let's say safety perception. How do I interpret it?
Like safety perception is basically depend of green view factor and this SVF is sky view factor. So these two things are important for safety perception. Like these two are dependent.
Positively important.
Positively.
So do you really believe green view factor is going to be positive for us?
No, because there might be some people, like notorious people, and because of bushes and everything, people might feel unsafe as well.
So you can question this, no? Go ahead.
So everything is not normal life. Means you sum up GPA, SPA. Does it sum up to 1?
Is there any scale, normalized scale?
No,
It should be.
it should be.
Means they are just showing the numbers up to these values, but it's a normalized scale.
And I think there is no negative here.
Yes,
You have taken
only
one.
positive.
Absolutely.
Yes, sir.